Hi everyone, welcome to this short overview of the CIPHE pipe sizing calculator. In this video we'll look at how the app helps you calculate mass flow rates, velocity and pipe sizing using real engineering principles, all in just a few seconds. Start by selecting your pipe material and diameter. For example, copper table X with a diameter of 35 millimeters. Next, set the water temperature, as this affects the density and viscosity of water, both critical for accurate pressure drop calculations. Then choose how you'd like to define the load. You can enter the mass flow rate directly, or let the app calculate it for you from the heating or cooling load and the temperature difference. When you enter a heating load, the app automatically applies the mass flow equation, Q divided by Cp times delta T. For example, a 20 kilowatt load with a 5-degree temperature drop gives a mass flow of 0.954 kilograms per second. The app then converts this to volumetric flow rate using the water's density at your selected temperature. For a 50 degrees water temperature, the volumetric flow rate is then calculated to 0.966 liters per second. Before we calculate the results, let's take a quick look at the preset limits shown on the two gauges. When sizing pipework for heating systems, it's good practice to aim for a flow velocity between 0.75 and 1.25 meters per second, and a pressure drop between 200 and 450 pascals per meter of pipe. These ranges give a good balance between efficient circulation, low noise, and minimal wear on the system. However, in real-world design, you might find that the velocity is spot on, but the pressure drop falls slightly outside that ideal range. That's where engineering judgment comes in. For example, if you achieve a perfect velocity, but your pressure drop per meter is a little high, you'll need to keep an eye on the overall system pressure loss, especially when you're calculating pump duty and checking the index circuit. Next, when you hit Calculate Results, the app runs the Colebrook-White equation to work out the friction factor based on your selected pipe size and flow conditions. From there, it calculates both the pressure drop per meter and the flow velocity, giving you the key data you need for accurate and efficient pipe selection. Once the results appear, you can instantly see whether your design falls within the recommended limits. In this example, the flow velocity is 1.16 meters per second, which sits perfectly within the target range of 0.75 to 1.25 meters per second. The pressure drop is around 399 pascals per meter, also well within the ideal range of 200 to 450 pascals per meter. These results indicate a well-balanced system, one that maintains good circulation, operates quietly, and minimizes the risk of pipe erosion over time. In summary, the pipe sizing calculator brings together solid engineering principles and a simple, intuitive design, helping you create balanced, efficient, and standards-compliant systems in a fraction of the time. This simple tool has been developed to support the learner, the tutor, and as a reference point for those more experienced engineers. Thanks for watching, and give the app a try yourself to see just how quick and easy accurate pipe sizing can be.